Hey class, today we're going to start section 3, which is measurement, but we're going to work on part 2. Remember in part 1 we looked at scientific notation, and today we're going to ask the question, what units do scientists use for their measurements? So whenever we make a measurement, we want to make sure we include the number that we're given as well as units. The measurement system that scientists use is called the SI, or the International System of Units. Sometimes we refer to this as the metric system. So SI is just an abbreviation for a French term here, the Système International des Unités. I can never say that correctly, but we have it there. Again, this is a revised version of the metric system, so if I call it the metric system, I'm talking about the same thing. This was originally developed in France in 1791. Now, scientists around the world use the same system of measurements, and the reason for this is because that way we're able to easily interpret one another's measurements. It would make no sense for one country to use grams and then another country to use ounces. So if we all use the same system of measurements, there will be no confusion, hopefully. So in the SI unit of measurement, there are two basic units that we're going to talk about. The first type we're going to talk about is something called a base unit, and then we're going to talk about something called a derived unit. So the SI system is built on 7 metric units known as base units. In other words, they make the base or the foundation of this metric system. So in SI, for example, if I were to measure the length of something, and in case you were wondering what length meant, it's a straight line distance between 2 points. The unit that you're going to typically use is called a meter, abbreviated with a lowercase m. However, if I asked you to measure the mass of something, which is defined as the quantity of matter in an object or sample, the unit that we're going to use is the kilogram, which we use kg to abbreviate kilogram. Those are just 2 of our 7 base units. There are others. So we already talked about length. We already talked about mass. Other ones that you're going to look at this year is temperature. Temperature's unit is Kelvin, and its symbol is a capital K. We also work with time as well this year, and the unit is second, which is abbreviated with an S. Sometimes you might see abbreviated as an SEC, depending on what table you're looking at. And then these 3 down here, we don't really hit in physical chemistry, but I do hit the amount of substance or the mole when I get into regular chem or advanced chem. In addition to those 7 base units, we have something called derived units. And derived just means that they are going to be combinations of base units. This is taking 2 base units and combining them by either multiplying or dividing these units. 2 common derived units that you will hear a lot is volume and density. Volume is the amount of space taken up by an object. So for example, if I asked you to find the volume of a cube, we know that this is length times height, which is another type of length, times width, which is another type of length. So in other words, it's the unit meters times meters times meters, which actually will equal meters cubed. So again, we're taking a base unit of length and multiplying it 3 times. Density, on the other hand, is the ratio of an object's mass to its volume. So for example, we take the base unit of mass, which is kilograms, and we're dividing it by our base unit, or our derived unit of volume, which is meters cubed. So typically density is given kilograms per meter cubed. There are other units, but this is the base unit or the common unit that we use, the SI unit, I would say. So again, density is our unit for mass, which is kilograms, divided by our unit for volume, which is meters cubed. Okay. So specific combinations of combining these base units will give different derived units. So we already talked about volume and we already talked about density, but area, if I asked you to find the area of a rectangle, you would tell me length times width, which is another way of taking a length times another type of length, meters times meters, to get meters cubed. Another one we'll look at is Pascal, which is pressure. Pressure is taking right here kilograms, the unit for mass, dividing by the unit for length, multiplying it by the unit for time 2 times. Energy is also another one that we'll look at. Energy is written as a joule, which is a capital J. And then the bottom two we don't really hit on, but I do talk about frequency when I get to chemistry. So to derive the SI unit for density, you can actually divide the base unit for mass by the derived unit for volume. We already said that. Density equals mass divided by volume. So here, dividing kilograms, because that is a unit for mass, kilograms, by cubic meters, so that is meters cubed, will give you the SI unit for density, kilograms per meters cubed. A bar of gold has more mass per unit volume than a feather, so we can say that gold has a greater density than a feather. Along with these base units and these derived units, we have something called prefixes. Prefixes, they are written in front of a unit. So the metric system is not always convenient one to use. For example, kilogram might be too big of a unit to use for something that you're measuring, like, let's say, a powder of something. Or, for example, a gram might be too small of a unit if we're trying to measure how much a person weighs. So we have something called prefixes, and it allows us to more easily write a number. And this prefix indicates how many times a unit is multiplied or divided by 10. So there are different prefixes that we're going to work with. The big ones that we're going to work with is going to be kilo, deci, centi, and milli. When you get into chemistry or advanced chemistry, we will work with the bigger units, but these are the 4 that we're going to work with the most. Kilo is a lowercase k, deci is a d, centi is a c, and milli is an m. Notice here they all have their own specific exponents as well. So here we have 10 to the third, deci is 10 to the negative 1, centi is to the negative 2, and milli is to the negative 3. This just means kilo. This is 10 to the third, or 1,000 times bigger than whatever base unit you're working with. Deci is 10 to the negative 1, so it's 0.1 smaller than your base unit. So here's a couple examples. We're going to look at one where we use a small base unit and then one where we look at a large base unit. So it says the time it takes for a computer hard drive to read and write data is in the range of thousands of seconds, such as 0.009 seconds. Using the prefix milli, and if we go back to our chart, milli means 10 to the negative third, or in decimal form, 0.001. Oops. So 0.001 milli, you can actually write this value, this number right here, as 0.009 seconds. You can actually change it to 9 milliseconds. Again, this number and this number are the same, and the reason for that is it all comes down to the units. Here we have seconds, and then this is again millisecond. So 9 milliseconds equals 0.009 seconds. Okay. Another example, if we're looking at a bigger number, we can also look at the distance of 12,000 meters and rewrite it. So this 12,000 meters can actually be rewritten as 12 kilometers. So again, this number and this number means the same thing because it comes down to what do the units mean. Metric prefixes can also be used for non-metric units as well. For example, if you work with computers, you might say that know the difference between a gigabyte or a terabyte, especially if you have a PlayStation and you're trying to save games on it. If I said I had this many bytes, we can actually bring that down to just say a gigabyte. Or if you work with cameras, instead of saying a million pixels, we can say 1 megapixel. So how are they able to do that? How are they able to say that 12 kilometers equals 12,000 meters? Well, in physical science, we're going to teach you just the basic way to do it by moving the decimal. When you get into chemistry, we'll work with bigger units and we won't work with the stair-step method, but right now, just to introduce you to this idea, we're going to work with the stair-step method. So a couple things to know is prefixes, and I would write this down in your notes. Prefixes must be used with a base unit. It has to. So what counts as a basic unit? A basic unit would be something like m for meter, or capital L for liter, or S for second, or even G for gram. Again, it's a single letter by itself. So if I look at these units down here, my base unit is actually right here because it is a single letter by itself. Gram. In order for it to be a prefix, it has to be used in conjunction with one of these letters. So for example, deci, its prefix symbol is a D. And so here, if you were going to use deci, you could do ds, decasecond, dl, deciliter, dm, decimeter, or dg, decigram. Deci is 0.1, or we can say it's 10 to the negative 1. Centi, its symbol that we use is C. And here, deci means 10 to the negative second. Notice down here we have a C. And so this is my prefix and L is my base unit. This means centa, liter. Here, centimeter. Here we have milli. Milli is an M. Again, milli means 10 to the negative third. You have to use it in conjunction with a basic unit. Milligram, millimeter, milliliter. Deca, we won't really use, but deca symbol is actually DA. It's not a one-letter symbol, it's a two-letter symbol, but we won't use those. It means 10 to the first power. Hecto is an H, that means 10 to the second power. And kilo is a lowercase k, and it means 10 to the third power. So how is this going to work? So the way it's going to work is you are actually going to look at your number that you're given. So here I'm given 0.15 kilograms, and you're going to find out where you're starting. Here I see the prefix K, so I'm going to start here at our kilo. And it says I'm going to G, which is not a prefix, it's just a single letter by itself, so it is a base unit. So you're going to count, in order to get down to the basic unit, you must go 1, 2, 3 times to the right. And that means your decimal has to go 3 times to the right. So we must move our decimal 1, 2, 3. So we have the 1, the 5, and then we have to put a 0 here to fill in that space. And notice my decimal is at the end now. So 0.15 kilograms is the same thing as saying 150 grams. Let's look at the second example, 92.4 centimeters. So again, we have to find out where we're starting. Here we're starting at C, which is centi. And it says we're going to millimeters. Milla, is a prefix. So here we are, if we look up here, if we're starting at centi, in order to go to milli, we must go to the right 1 time, which means our decimal should go to the right 1 time. 92, the decimal's longer there, 4, 924. Okay. Even if we did a bigger jump, let's say we had 45,500 centiliters, we're starting over here at centa, and it says we're trying to get over here to kilo. We're trying to get to kilo. So we have to count 1, 2, 3, 4, 5 hops. Notice my hops are to the left. So here I don't see a decimal. Remember, a decimal is always assumed to be at the end. So I need to take 1, 2, 3, 4, 5 hops. So my decimal now is in front, 455. If you want to add the zeros, you can, but you don't have to. You can drop those off. And 0.455 kiloliters. And that's the end of today's lesson. If you have any questions, please make sure that you guys ask, and I hope you guys have a great day.